Today's topic is about logic gates. So the circuit components. In this circuit component, we will discuss how these components work in the circuit. You don't have to learn all specific circuit component. First, we will start with the logic gates. Then diode, light dependent resistor, also known as LDR, thermistor, variable resistor, relay, and fuse. So these are the circuit components we will discuss. Logic gates, diodes, light dependent resistor, LDR, thermistor, variable resistor, relay, fuse, and then earthing. First, what is a logic gate? What are logic gates? Logic gates are combination of the switches. When switches are arranged in a different pattern or a manner, what we call them as a logic gate. And what is the logic of the switch? Like for a switch can be open. Open means not connected, or you can say off, or you can say zero, or you can say low. So a switch can have a logic. A switch can be open. Open switch means not connected, or you can also say zero, or off, or you can say low. Or a switch can be close. So when we say a switch is close, what's the meaning of a closed switch? Closed switch means connected, or it is on, or it is one, or it is high. This is a second logic. So a switch can be open or a switch can be closed. Open switch means not connected. Closed switch means it is connected. That is why, like example, you will see some of the switches, instead of writing on and off, what they write 0 and 1. So why? Because actually 0, when you press 0, it means you will off the device, switch off the device. And when you press 1, it means the device will work. So on and off, instead of writing on and off, 0 and 1. Sometime a same switch can also be used for on and off. And if same switch is used for on and off, you will find this symbol. Maybe you have seen, like for the power, a power switch, you will find this symbol is there, a power button or a power switch. So what is the meaning? Actually, it's a combination. You have seen this like on a remote control. If you switch on the television or switch off, you use the same button. So if same button is used to on and off, so actually it's a combination of 0 and 1. 0 means off. When you press one time, it will be off. When you press next time, it will be on or 1. So when same switch is used for on and off, you will find this symbol. Is it clear? The concept is for a logic gate. So logic gates are combination of the switches, arrangement of the switches. If it is high, we will say on. If it is off, we'll say low. And the logic gates which you have to learn, many are there, but you have to learn OR gate, how the OR gate work, AND gate, NOT gate, NOR gate, NAND gate. So these are the 5 gates which are part of your syllabus. OR, AND, NOT, NOR, and NAND gate. So I will explain each gate today. It's not a difficult topic. It's a very easy topic compared to other parts. So we'll discuss the circuit components, logic gates, diode, LDR, thermistor, variable resistor, relay, fuse, and earthing. The first one is the logic gates. Logic gates are basically combination of the switch. A switch can be open, it means not connected, off, 0 or low. Or switch can be closed. Closed switch means connected, on, high, or 1. And if you're using like some buttons are there, you will find it's written 0 and 1. So the term 0 means off and 1 means on. And if you are using a same button to switch on or off the device, then this symbol you will find, actually this symbol is also a combination of 0 and 1. So when you press one time, it is off, and when you press another time, it will be on. So the logic gates, which are combination of the switches, you will learn about 5 logic gates. You don't have to learn internal working. You will learn the circuit symbol and how it works, like input and output. So first gate we will start with. You can copy this part. So we will move on. So the first one is known as the OR gate. First, the circuit symbol. The circuit symbol for OR gate this is a circuit symbol for OR. And it is having 2 inputs. and one output. This is in input one. This is the second input, means where the current can enter or pass. And this one is the output. So how this logic gate works, working of this logic gate. So if we make a table for inputs and output, so how it works, it depends on the input. Like what are the combination of input, and with respect to that, we'll get output. The easy way to remember the output for OR gate, how to get the output is by addition. Like add the input and you will get the output, the result. So example, if both inputs are 0, 0 and 0. So if both of the inputs are 0, 0 plus 0, what will be the output? So the output will be 0. So what is the meaning? It means if both inputs are 0, like if input there is no current, if input there is no current, then output will be 0, and output there will be no current as well. If one of the input is 1, another one is 0, 1 plus 0, because we get the add input to get the output. So 1 plus 0. So we will get 1. So what is the meaning? It means like if one of the input is high and another one is low, so this logic gate will allow the current to pass through it, or so the output will be high. If one input is 0, the other one is 1. So 0, again it will be 0 plus 1. So 0 plus 1 is equals to 1 as well. So if first input is 0 and second is 1, the output will be 1. If both inputs are 1, 1, 1, what will be the output? So 1 plus 1 is 2. That's right. But the thing is, this is a logic gate. So logic gate only give an it's only having an idea like whether it will work or it will not work. So 1 plus 1 is 2. What does it mean? But we don't write 2, we'll write 1 only. Reason why we write 1, it means that the device will work. So 1 means it will work and 0 means it will not work. So when both inputs are high, the output will be high. So 1 plus 1 is 2, but in terms of logic gate, 1 plus 1 is 1. Means if both inputs are high, the output will be high, or the device which is connected to the output will work. So the working of OR gate, if they ask in exam, sometimes they ask explain the working of OR gate. You can make this table. This is called a logic table. You can draw this logic table, or you can use the words to summarize this. How we can use words to summarize this? We can say when both inputs are low, the output will be low. But if one input is high or both inputs are high, output will be high. Is it clear? The first kind of logic gate. We will discuss the application also where we use these logic gates. But first thing is you should understand what will be the output for a specific inputs. Is it clear? The OR gate. OR gate is a combination of switch as well. What are the conditions it works? So to understand the output, we will add the input. Addition of input will give us the output. So 0 plus 0, it's 0. 1 plus 0 is 1. And 1 plus 1 is also 1. Copy this part. Then the second type of gate is known as the AND gate. So basically what is the AND gate? First the circuit symbol for this AND gate. Circuit symbol is easy to remember, the circuit symbol for AND gate, because you can see the letter D is there. So its symbol is also resemble with letter D. And it is also having two inputs and one output. So this one is input. Input and there is output. The working of AND gate. So the working of the AND gate, to remember how it works, just multiplication. So multiplication of input will give the output. So example, again, we'll make a truth table. The two inputs and there is one output. So input, input, and there's output. So how we get a result for AND gate? AND gate, when both in by multiplication of the input, we will get the output. So example, if both inputs are 0, 0 and 0, so 0 multiplied by 0, what will be the output? So 0 multiplied by 0, it will be 0. So the output will be 0. Means if both inputs are low, the output will be low. if one input is high and the other one is low. So 1 multiplied by 0, what will be the answer? So 1 multiplied by 0, again it will be 0, so output will be 0. Then 0 and 1, what will be the output? So it will be 0 again. And 1 multiplied by 1, what will be the output? So that's equal to 1 multiplied by 1 is 1. So if both inputs are high, the output will be high. Where we use this logic gate, like example, as to draw a cash from the machine, ATM, there is a logic gate, AND gate is there. How this AND gate is there? Basically, the machine is taking two inputs. One is the card. Card is a one input, and pin is the second input. And as a result, what you will get an access to your account. So example, when you insert a card, the machine read the card. So if the machine read the card, it will give 1. Like one of the input is 1. If you use the card which machine can detect or read, so the card input is 1. But you enter a wrong pin, like you did not enter a pin which matches with the card. So the pin input will be 0. So if one combination is, one of the input is 1, correct, and another one is 0, as a result, 1 and 0, what will be the output? So the output will be 0. So output is 0. It means that you will not have access to the account. It will block your access to the account. But for example, a machine read your card and you enter a right pin, correct pin, because every card associated pin is there. So when both inputs are 1, so what will be the output? The output will be 1 and you have access to your account. Yeah, all the machines, these are digital binary language or Boolean algebra. So 1 and 0 is a computer language, means it's a state, like whether a device will work or it will not work. So AND gates are used in ATM when you want to withdraw a cash from the machine. So you insert a card. How it is linked with electricity? When you insert a card is having a chip, means that's made up of a conducting material. So when it is made up of a conducting material, the current is able to pass through that slot. That's why it is 1. And when you enter a correct pin, because every card associated pin is there, when you enter a correct pin, actually it generates an electrical signal, current. When you press the button, actually you're developing a current. If that current, amount of current matches with the input card, then both inputs are high, so the output will be high and you have access to the account. Is it clear, the concept? How this is put in a circuit? It is linked, actually the card is having a chip. When you insert a card and when you enter a pin, because your ATM machines need electricity to work, so when you press the button, it is generating a specific current, so it is generating an input. Is it clear, this part, the AND gate? Then the third gate is known as an inverter. So inverter, what is an inverter? Basically inverter, it changes or it invert the input to opposite output. The circuit symbol, look, these are circuit symbols. These are not the complete, like internally they have more components inside these logic gates, but this is just a circuit diagram. So you just have to learn the circuit diagram, and if what is the input, what will be the output, that's it. They will not ask explain how this work in detail, in depth. Only you have to explain working in terms of input and output. So circuit symbol for inverter. Yeah, this is also a gate. AND gate is there, OR gate is there, NOT gate, which is also called inverter. The name of the gate, this is called a NOT gate, also known as inverter. The circuit symbol for NOT gate, sorry. This is a circuit symbol. Why we call this as a NOT gate? Compared to other gates, they have two inputs, one output. But for NOR gate, there is only one input and one output. And if input is 0, output will be opposite, 1. If input is 1, output will be 0. That's why we call this as inverter. So when we make a logic table for inverters, I will explain the application of inverter as well. So if input is 0, the output will be 1. If input is 1, the output will be 0. Yeah, how the if input is 0, the output is 1? Because they have their own supply, batteries. So where you have seen this, maybe you have heard it is having its batteries. It's not generating electricity. There are batteries which store electricity, which store electrical energy. Maybe you have heard this UPS, uninterrupted power supplies. So what is the UPS or uninterrupted power supplies? So how it works, like example, if this is your house, and you're receiving the electricity from the power supply company. So this is what you receive from the company. Now, how it works? Example, this is a UPS or inverter. You can say inverter as well. So one of the line is going to this inverter and the other is to the house. So what happened, for example, a power supply or a company is providing you electricity. So when they are providing you electricity, means electricity is coming to your house, it means 1. When the current is flowing, it means 1. So when this is 1, your device, the home appliances are receiving electricity. For inverter, the input is 1, but the output will be 0. So inverter is not giving electricity, you're receiving the electricity from the main supply. But suddenly, if there is a power failure, it means the company is not providing you electricity, so the input is 0. So if input is 0, your devices will not receive electricity from the company. The inverter input is 0. If inverter input is 0, then inverter, it's having the batteries which supply the stored energy. So the output will be 1 and your devices will work on the basis of electricity provided by the inverter. So this is why it is called uninterrupted power supply. Means if there is a power failure, the inverter will supply you energy. Is it clear? So what is there inside in this inverter? There is a NOT gate. No, the inverter AC is which is, this is called a DC inverter. Actually, there is a difference. A DC inverter, basically, they are using converting AC to DC and using the electricity. That's called DC inverter. What is the meaning of DC inverter? Means it's converting alternating current into direct current. That also you will discuss in a diode topic. So DC inverter is a bit different thing as compared to the DC. Look, the inverter ACs, when we say inverter AC, it is inverting the inputs and output as well as it is converting AC to DC. So that's a bit different thing. And stabilizers, what are stabilizers are known as the relays. Stabilizer is not the inverter, it is because stabilizer stabilize the voltage, like make a constant voltage. It's not using inverter. So what inverter will do, if input is high, the output will be low. And if input is 0, the output will be high. So example, you're receiving the electricity from the company. If, for example, if there is a power failure. So if there is a power failure, it means the company is not able to provide you electricity. So the input for an inverter or NOT gate will be 0. If input of a NOT gate is 0, the output will be 1 and you will receive electricity from the gate. There's also another application of this. There are many in digital circuit. We can use NOT gates. Maybe as you are using, like if you are driving a car, there is a symbol, there is a indication lamp for the seat belt. Like it shows that the seat belt is not fastened. So what is the meaning, or what is there inside? You can see if this was a metal part of the seat belt, this is a buckle and with a metal part. For example, you did not connect the seat belt. You did not fasten the seat belt. Your car is having a battery is supplying electricity. So as this circuit is not complete, if this, because the seat belt is not fastened or the buckle of the seat belt is not connected, so it means it is off. So when it is off, the input is 0. If input is 0, the inverter is there, so the output will be 1. So if the output is 1, the indicator lamp will be on. Indicator lamp will be on, that it shows that a passenger or a driver did not fasten the seat belt or did not completely connect this buckle. But as you connect this, the metal part, you will find this, the buckle of the seat belt, the front side is metal. So what is the reason why it is made up of metal? So the moment you fasten the seat belt, you connect this metal part. So when you connect this, now because there is a battery, the supply is there, that metal part is a conducting part, so allow the current to pass. When the current is passing, what will be the input for NOT gate? The input for the NOT gate will be 1. If input is 1, the output will be 0. And what happened to the lamp? The indicator lamp will switch off. Is it clear? The indicator lamp for the seat belt in the car also uses a NOT gate or inverter. Then another gate is known as NOR gate. Basically, what is a NOR gate? NOR gate is a combination of NOT and OR. So when NOR N from here and OR from here, what it result? It will result in a formation of NOR gate. And what is the circuit symbol? The circuit symbol for the NOR gate. Look, this is OR gate. This is OR gate. And if we connect a NOT in front of that, like make a circle, what it makes? It will make NOR gate. The result is the same. If you remember, for OR gate, we get the result by addition. But final result will be invert. Like this one is input. This one is also input. That's the final output. So the final will be opposite. For OR gate, all the final result will be changed. So input, input, and output. So example 0, 0. What was the output of OR gate? If there was a OR gate means by addition we get the result. So output of OR was 0, but because it is a NOR, so it will invert that. So what it will make? It will make 1. 1, 0. What will be the output? Output of OR was 1, but it will make it 0. 0 and 1. What will be the output? 0 and 1 is 1 addition, but the final output will be 0. And 1 and 1, so 1 and 1 is 1, but the final output will be 0. So you can see that all of the inputs of, sorry, the output of OR gate are inverted. When you check the OR gate, you can see the OR gate, it was 0, 1, 1, 1, but it is a NOR gate now. So when it is a NOR gate, it is 1, 0, 0, 0. And the last kind of gate is known as NAND gate because it is related. So I'm just quickly going through this. That's called NAND gate. NAND gate is a combination of NOT and AND. So N from here and AND from here. So what it will make? It will make NAND. So all of the output of AND gate will be inverted. This will be the circuit symbol. Input, input, and output. So yeah, so the result, because for AND gate is by multiplication. So first we will multiply and then we will invert. So 0, 0, 0 multiplied by 0 is 0. But because there is an inverter, so it will make it 1. 1 multiplied by 0, it is 0, but inverter will make it 1. 0 multiplied by 1, it will be 0, but the inverter will make it 1. 1 multiplied by 1, the inverter will make it 0. So you can see the output will be 0, the final, because 1 multiplied by 1 is 1, but as the final it is inverted, so it becomes 0. Where we use this logic gate, the NAND gate is used for indicator. Also it is used in a car system, door indicator. Like example, just for explanation, I making a simple example. Like if you have a sorry example, your car doors. So if you have a 2-door car, so the inputs are the doors, and you will also find, like example, the point where the doors connect to the car, that is also made up of metal. Why they are made up of metal? Because it can conduct electricity, so it can be used as the input for the circuits. Example, you have door 1 and door 2. You forgot to close the door properly, like door is open, the door 1 is open for the car and the second door is also open. So 0, 0, what will be the output for the NAND gate? It will be, because the door is open means 0. So if both inputs are 0, the output will be 1. If output is 1, the indicator lamp will be on. so that the lamp or indicator or warning lamp will show that the doors are not properly closed. But if you close one of the door properly, yeah, beep is also instead of lamp, you can have a buzzer. So if buzzer is there, then you will hear the sound. If one of the door you close properly, another one is open. So if one of them is 1, another one is 0. So output will be 1. Again, it means the indicator lamp or the buzzer will sound. Like you will hear the buzzer or you will but if both of the doors are properly closed, so it means when they are closed, it means 1. They are allowing the current to pass. So if both inputs are 1, the output will be 0. The lamp or the buzzer the lamp will be off or the buzzer will not ring. So this is the application for NAND gate. Is it clear? So what you have to learn, these logic gates, the circuit symbols, and the input and the outputs. So okay, I will it's 10:30, so I will end the class at this moment, and tomorrow we'll do questions related to the logic gates. And I will explain the remaining circuit components tomorrow.